Assalamualaikum and nice to meet everyone. Thank you for clicking this video. So for today, we from section 4 from the first group are going to presenting our group project. The topic that was given to us was topic on mechanical stationery, where we must find any stationery that uses any mechanical properties. And out of all stationery out there, we chose a pair of compasses. Yes, compasses. First of all, before we start the presentation, I'm going to introduce you guys to my team members that work hardly to complete this project. First, myself, Muhammad Hamdi bin Khairul Anwar, number matrix AA230312. Next, Scott Mervin Young, AA231525. Amirul Akmal bin Amran, AA20440. And finally, our last member, Azmi Rega bin Muhammad Zafri, AA232597. Next, I'm going to pass to Azmi.
Assalamualaikum, I'm Azmi Rega bin Muhammad Zafri. So for the background of this project, a compass, also referred to as a pair of compass, is an indispensable tool for creating precise circle or arcs. Its versatility extends beyond just drawing, as it can be utilized for measuring distance, particularly on maps. With its wide range and application in mathematics, drafting, navigation, and more, the compass plays a pivotal role in our learning journey. It enables us to accomplish drawings that would otherwise be unattainable through freehand technique. In the past, compass and other manual drafting tools were commonly sold as a set with interchangeable parts before an advent of computer. However, as technology advanced, circle templates emerged alongside compasses in the mid-20th century. Nowadays, computer-aided design programs have taken over many of these functions, relegating physical tools like compasses to the role of teaching aids for subjects such as geometry and technical drawing. So, our objective for this project was to achieve the goal of transforming the tool into drawing, produce a detailed 3D representation of the object, which is compass, enhance comprehension of the tool, gain practical experience in utilizing AutoCAD software, strengthen proficiency in using AutoCAD software, establish a solid foundation in operating AutoCAD software. Our team of 4 individuals successfully complete a project centered around mechanical stationery. We transform a compass into a drawing, which each member is responsible for creating one or two drawings of the various parts and the final assembled product. To ensure accuracy, we utilized a digital vernier caliper for measurement. The drawings were meticulously crafted using AutoCAD software, featuring orthographic views for each part, as well as isometric and orthographic views for assembled part. The project spanned 4 weeks, with the first week dedicated to measurement and report writing. The second week is drawing session. The third week was preparing our presentation on the project result, and the final week for submission.
Hello, my name is Scott, matrix number AA231525. Today I'm gonna present about the literature review for the history of compass. First, drawing compass are found in the archaeological digging site of ancient Rome. Next, every drawing compass before the 18th century didn't even have a pen but a needle, so it scratched the surface instead of drawing it. And Galileo Galilei designed his first geometric and military compass in Padua in 1597. With the help of a craftsman named Marc Antonio Mazzoleni, the geometric and military compass of Galileo Galilei is finally brought to reality. So there are 4 types of compass in the market right now. First is a beam compass. A beam compass is made of brass or wooden beam and is used for drawing circles larger than a regular compass. Next is a scribe compass. This type of compass is the most simple by its form. Carpenter used the scribe compass to scribe a circle instead of drawing it on the wood. Next is a loose leg divider. A loose leg divider are made of all forged steel and used to scribe circles too. Loose leg wing dividers are also provide stepping of repetitive measurement with particular accuracy. Lastly is proportional compass. The military used the proportional compass, the sector from the 16th to the 19th century to do calculation. It is a tool consisting of two rulers equal in length and joined by a hinge.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Akmal bin Amran with metric number AA230440, and I will explain about the methodology. So, as we can see, we use compass as the object of our project. The picture on the right is the real compass, and the picture on the left is the 3D drawing compass. Next, I will explain about the material used and the functions of each component of the compass. First, screw. The material used for the screw is aluminium, and the function is to tie every component together. Second, we have nuts. The material used is aluminium, and the function is to tie every component together. Third, we have leg with pencil holder. The material used is aluminium, and the function is to place our wooden pencil. Fourth, we have plastic top part handle. The material used is plastic, and the function is to tie together the leg with needle and leg with pencil holder. And the last one is the leg with needle. The material used for this leg is aluminium, and the function is as the staple to a paper at the drawing points intended. Then, I will explain about the activity analysis for the compass. For customer activities relating to using and retiring a product activity analysis, it is divided to two parts, which is how to use it and the retired procedure. So, for use, first we need to set up, then operate the compass. The third one is to maintain the compass, and the last one is to repair the compass. For retire, the first procedure is to take down the compass, disassemble the compass. The third one is to recycle the compass, and the last one is to dispose the compass. This is the activity analysis list for compass drawing tool use and retirement. So the first procedure is to open the package. Second, examine the component of the compass. Third, put the compass in the pencil box. All of this step is the setup for use of the compass. The fourth step is to take out the compass from the pencil box. Next, insert the pencil into the pencil holder. After that, make sure the pencil tip and the needle are at the same length. Decide where to put the center of the circle or arc to be on the paper. Then, mark the center point with a small dot using the pencil. Use ruler to measure the desired radius. After that, spread the compass legs to the measured distance. After we spread the compass leg, we need to place the compass point on the marked center point. After that, rotate the compass around the center point firmly. Repeat this step until the pencil needs replacement. Make sure to put back in the pencil box after use the compass. This is the step how to replace the pencil. So the first one is we remove the pencil from the compass. Then we install the new pencil to the compass. We need to repeat this step until the compass is no longer can be used. The last step to retire it is dispose the compass by recycle or thrown out the compass. So, this is function decomposition diagram of a geometry compass. A product function decomposition subdivides the major functional requirement into its respective subfunction. The function decomposition diagram is a hierarchical structure of functions not forms. The diagrams help us to identify whether functions are connected and where the interface connection might be. For example, let's examine a function decomposition diagram of a geometry compass as shown. This is the product component decomposition diagram of a geometry compass. Compass decomposition diagram illustrate the hierarchical structure of component forms, not functions. As we divide each assembly into their own components, however, we can obtain a better overall understanding of how individual components interact with each other and ultimately contribute to the overall product function. Diagram shows the black box and the interaction diagram. As we can see, at the geometric compass tool for black box diagram, it shows three parts. The first one is your drawing point, then centering points, and the last one is adjustment mechanism to set the radius. Now I will explain about the interaction diagram. This is the interaction between the user and the compass tool. The user holds compass point at center mark and the compass draws circle or arc. Then, the user adjusts compass to set radius to draw circle or arc on the paper. Last, the user review and adjust as needed to final the drawing on the paper.
In conclusion, Compass was really an amazing tool that has been made amazingly. This tool have helped many engineers to express their idea of engineering into a drawing that act as a form of language for communicating idea to everybody, intended because it is surpassing any other language barrier that act as obstacle in exchanging information among engineers. Although nowadays engineer was not using it as frequent as engineers before due to the existence of AutoCAD software, it really have played crucial parts in the making of creating many early technology breakthrough, even assisting the creating of concept in AutoCAD. Converting this tool into drawing certainly was not an easy task because of the well-made and precision of all the parts with detail. It was a challenge that we have overcome in order for us to be better at what we are doing. After finishing this project, we explore more about AutoCAD software and become more familiar handling and using this software. Also, this project show us the potential AutoCAD bring us to make drawing that seem impossible to draw with precision. Now we can confidently say that we got great base of handling AutoCAD in order to be professional in using AutoCAD and create more precise and complicated products. With the knowledge that we already possess, it will be a great asset for us if the pursuit in being better in drawing using AutoCAD software do not stop. Being a professional drawer will open up many career opportunities because drawing one of the key of technology breakthrough that happen in our world. Finally, thank you very much everyone for listening to our presentation. Sincerely from Group 1. Bye.